Take a close look at this picture. You're probably seeing an alternating pattern of purple and orange hearts. But what if I told you that those hearts are exactly the same color? You can prove this by taking away all the stripes. So, why does this happen? Well, if you zoom in on the picture, you'll find that the striped bars aren't actually the same color. These surrounding blue bars make the heart seem purple, whereas these surrounding green bars make the heart seem orange. This gives us a vital clue on how our vision works. It suggests that we perceive an object's color not based on its actual color, but on how it compares to the surrounding colors. Illusions like these expose the visual system for what it really is, a brain using a biased set of rules to process optical signals. The result is what we call vision. In fact, optical illusions are one of the few ways we can figure out exactly what these biased rules are. Here's another example. Believe it or not, this outer line is blinking in exact alignment with the spinning line. Yet, it seems as though the outer line is lagging behind the rotating line. This is known as the flash lag effect. What does this reveal about our vision? Well, turns out we're living ever so slightly in the past. When we see something with our eyes, it takes a small amount of time for the signals to reach the brain and then for the brain to process this information, roughly 80 milliseconds. So, the reason why you're seeing this lag is because in the 80 milliseconds after the line is flashed, the rotating line has moved forward a bit. Your brain incorporates this information and thus we see the rotating line a bit further ahead of the flashing line. Now, this 80 millisecond time lag can be exploited to produce other strange phenomena. In one experiment, researchers had participants press a button that would cause a light bulb to flash. When they reduced the delay between pressing the button and flashing the lights to 80 milliseconds, participants would say the light bulb flashes instantaneously. But when you reduce it even more to about 40 milliseconds, participants would say that the light bulb flashed before they even pressed the button. Once again, we see that our vision can't fully be trusted. Here's one last illusion. Focus on the center of the image for around 20 seconds. Keep focusing and don't look away. Now, I'm about to show you the same picture but in black and white. After I switch the images, it's important to continue focusing on the center. Ready? There. Are you seeing color? Eventually it will fade away, but for that brief moment, the colorless photo has color. What's happening here? Well, your eyes have color receptors called cones that detect red, blue, and green. We see colors based on the different levels of activity across these cones. For example, if the red and blue cones are firing a lot and the green cones aren't, we'll see purple. Now, when you stare at a particular color for too long, e.g. purple, the red and the blue cones for that particular area gets tired and doesn't work as well. So, when you look at this new image, you only have the green cones working normally, and as such, your color vision is inverted. In fact, this is what that picture looks like when you invert the colors on paint. Notice how the purple trees turn green? This color scheme is what you should have seen on the black and white after image. Overall, these examples all show the importance of optical illusions in helping us understand our visual system. So, next time you see an illusion, try and figure out exactly what's going on.